Okay, let's take another look at a series circuit here. We have three resistors in series. You have a variety of different values up on the screen in front of you. Let's take a look at some of these values here. I have an amperage total of 500 milliamps. I have resistor 1, which is 100 ohms, resistor 2, which is 200 ohms, and resistor 3, which is again 100 ohms. So let's take a look at this 500 milliamps over here, and I just want to touch on this. That 500 milliamps may sound like a lot of current, but actually it's not a lot of current because it's actually milli. And I'm not going to get into an engineering notation exercise. You can look for my video on engineering notation, but 500 milliamps really is equal to 0.5 an amp, or half of an amp. So when we're doing our calculations for ease, we're going to think of this 500 milliamps as 0.5 of an amp. Okay, so let's take a look at what we've got here. So I've got three resistors in series, and Kirchhoff's law states that the amount of resistance in the circuit is equal to the individual resistors. So the total resistance is equal to resistor 1 plus resistor 2 plus resistor 3. So I have resistor 1 is 100 ohms plus 200 ohms plus another 100 ohms, which gives me 400 ohms. So my total resistance in this circuit must equal 400 ohms. Now let's take a look at our voltage. Let's do this value here. If we look at our Ohm's law triangle, we can determine that, well, if I want to find my voltage in a circuit, I can simply multiply my amperage times my resistance. So my voltage total must equal my amperage total times my resistance total. My voltage total must equal my amperage total times resistance total. Now, we're going to use 0.5 as a value because it's an engineering notation, so we're going to convert that to standard, and we're going to say that, well, 400 times 0.5 is going to give me 200 volts. All right, let's finish off our totals here, and let's take a look at power. So power over here is equal to my voltage times my amperage. So my voltage times my amperage, 200 times 500 milli, which is 0.5, 200 times 0.5, I must have a total wattage of 100 watts in this circuit. All right, so we're going to follow electron current flow, and we'll follow it here. We'll start over here. Since I have a series circuit, all of the current must go through the individual resistors. All of that current must go through here, and it must go through this resistor, and it must go through this resistor here. So in series circuits, we say that the value of current through a resistor is equal to the total current in the circuit. In other words, current doesn't change in a series circuit. It remains the same. So you can put that value in, and I'll put it in as 0.5 of an amp. And I'll just put in brackets here, well, that's actually 500 milliamps. And all the current must go through this resistor here as well. So I must have 0.5 of an amp here, and I must have 0.5 of an amp here. So now we can get on with some of our other calculations here. And let's take a look at our voltage at 1. Our voltage at 1 is equal to my amperage at 1 times my resistance at 1. So my amperage at 1 is 0.5, so my voltage at 1 is equal to 0.5 times 100 ohms, which is half of 100, which is 50 volts. So that's my voltage at 1, or voltage drop as we call it. All right, and my voltage at 2 must equal my amperage at 2 times my resistance of 2. So 200 times 0.5, 100 volts. And 3, exactly the same as resistor 1, the same values, 100 times 0.5, so we must have 50 volts. Kirchhoff's voltage law, Kirchhoff says that the amount of voltage drop around a closed loop must equal my voltage applied. My total voltage in this circuit equals my voltage at 1 plus my voltage at 2 plus my voltage at 3. So if I add up my voltages, I got voltage at 1, I've got 50 volts. And I've got voltage at 2 of 100 volts. And I've got my voltage at 3 of 50 volts. I have a total voltage of 200 volts, which is right. So that's just a way to check to make sure that you're on the right track. Let's do our individual power dissipation. So my power at resistor 1, looking over here, my power at resistor 1 must equal my voltage at 1 times my amperage at 1. So if we do this, my power at resistor 1 is 50 volts times 0.5 amps is 25 watts. Keep in mind that we have 100 watts total, so we have to make sure that when we're doing this to check that the individual power dissipations at the resistors must equal my total power. So let's just keep that in mind here. So let's do the next one. My power at 2 is equal to my voltage at 2 times my amperage at 2. My voltage at 2 is 100. My amperage at 2 is 0.5. So 100 times 0.5 means I must have a total 50 watt dissipation at that resistor there. Power 3 is the same as my resistor 1, as they're the same value. The amount of voltage is the same, the amount of current is the same, and the amount of resistance is the same, so the total power must be the same. And of course we can check that. My power at 3 is equal to my voltage at 3 times my amperage at 3. So I must have 25 watts here as well. So that's how you do a series circuit with 3 resistors, and you can see that the voltages work out. So 50 plus 100 plus 50 equals my 200 volts applied.